Hello and welcome back to our data structures and algorithm series. In this video, we want to look at how we can add a node at the end of a linked list. So let's have some visualization. So the algorithm is that you first have to create the node. For example, we want to insert the node with the data D. So we're going to create a node. Of course, it's going to be stored as a memory address, for example, 1044. Then we need to begin by checking the head. So is the head empty? Is it none? If it's none, then we simply point this particular node that we've created. We point the head to this particular node that we've created, meaning that it's the only node in our linked list. So that's the first condition. The second condition, which applies here, if the head has an address, then we simply traverse the linked list. So we traverse the linked list until we get to the very end of the linked list. So when we encounter the null value, we know that we are at the end. So what do? We point the next c.next. c.next, we point it to our new node. So it's going to point to 1024, right? So that is what is going to happen. And finally, of course, by default, our next was null, so we're not going to change anything there. So again, for a recap, in order to add a node at the end of the linked list, you have to traverse to the end, then change the pointer of the node at the end, the next pointer of the node at the end to point at the new node. So this operation, what's the time complexity? Yes, you guessed it right. It is actually O of n, big O of n. What about adding the node at the beginning of the linked list, which is what we did earlier? So because that one does not require traversing, so it's just an O of 1 operation. So let's jump right in to Visual Studio and do this. Okay, so here, inside the singly linked list class, we want to create a function. So let's call it a function to add a node at the end of the linked list. Okay, so to do that, we are going to use def, and then we can call it insert at end, like that. Of course, we are supposed to pass self, and it's also going to receive the data. So the very first thing to do is to create the node. So we're going to do new node is equals to, then we call the node class and we pass it some data. Because we're adding at the end, we can just add letter E at the end of this list. Oh, really, we're actually going to pass the value. So I'm just going to pass in the data because you're going to pass. So I'm just going to include that particular variable there. Then the next thing we need to do is to check if the head is none. So if head is none, like that, then we want to point the head to this new node, like that. So we're simply going to do, oh, this is supposed to be, you see, we have the wavy line. We have the wavy line saying head has not been defined. So always remember to do self.head. Okay, so this will be self.head is equals to the new node that we've created. Else, we want to we want to traverse the linked list to the last node. So to do that, we can create a variable called last. So self, yeah, we can just call it last is equals to, then self.add, like that. Then we can use a loop now to do the traversal like we used when we were traversing. So here we do last.next, like that. Then inside the loop, we say last is equals to last.next. So we are going to move to the next node until we get to none. When this condition becomes none, then we are going to get out of the loop. And when we get out of the loop, we want to say that because that is the last node, then last.next is equals to the new node that we created up there. So that is it about this function that is supposed to insert a node at the very end. So we can just scroll down and then go ahead and call it here. So my singly list dot insert at end, like that. Then we can just pass it, for example, letter E. So if we save our code and run it, we should be able to get E as our last node. So you can see on the terminal down here, we actually have E. So you can as well pass in something else, for example, F. And if you run this, we should get F at the end of it all. So my challenge to you is, of course, here the syntax is a bit different from how we did the traversal. You can see that in the traversal, we didn't use current.next here, but we used last.next. So I want you to play around with the debugger and just try to understand why we are using last.next here so that you can see it. And in case you have a question, feel free to put it on the comment and I'll get time to respond, or someone else can actually respond to you. The other challenge I want to give you is that you implement the insert in between method. So try and do that. In the meantime, in our next lesson, we can look at how to we can look at the search operation and also the delete operation. So thank you so much for sticking to the end. I hope you've understood this. See you in the next video. Bye for now.